So your true age is actually your immune age. And we can prove that because we can see it functionally validated in real life, real world evidence on the field, on the ground. And we moved from soccer to football to tennis. And that was a huge, huge insight, which today we are using in OS Lifetime, where we build cellular avatars cell by cell, and we understand being healthy at a cellular level for your entire health span. The other thing which happened, which might be interesting to our listeners, and I'll sort of postulate it as a question: why do centenarians not only live so long?
We like to believe that modern medicine sees everything. And we trust that if something were wrong, the standard test would catch it. But what if the map we are using to navigate our biology is fundamentally flawed? What if it is merely a low-resolution, black and white sketch of a high-definition Technicolor reality? Today's guest, Vijay Vaswani, confronted this terrifying gap personally. Despite having access to the world's best healthcare, he watched his father succumb to a virus that children easily defeat, simply because the medical system couldn't see the signal until it was too late. That tragedy turned him into a code breaker. As the CEO of Omniscope, he is now decoding the immune system at a resolution 100 times greater than current standards. We are about to explore the single cell problem, the hidden language of our immune memory, and why our true age has nothing to do with our birthdays. Welcome to the high resolution future. Vijay Vaswani is a biotech leader working at the frontier of artificial intelligence and precision diagnostics. As co-founder and CEO of Omniscope, he is advancing high resolution immune repertoire sequencing to decode how the immune system responds to disease, therapy, and environment. His career spans leadership roles at Illumina, 10x Genomics, Siemens Healthineers, and Meridian Bioscience, where he helped translate breakthrough genomic technologies into scalable clinical and commercial platforms. Across multiple biotech IPO journeys, Vijay has developed a rare ability to bridge discovery science with real-world healthcare systems. By illuminating the immune system as both a biological memory and a predictive signal, Vijay's work opens new pathways for earlier detection, personalized treatment, and a more anticipatory model of medicine. Welcome, 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 Vijay. It is such a pleasure to be speaking with you today.
Thank you, Jeremy. It's a pleasure is all mine. I've been following your podcast as well as your incredible background. So thank you so much to you and your listeners for making time for us.
Wonderful. You know, as I was getting acquainted with your digital twin for what it is today so far, you know, various ventures that you've been involved with, you know, I was, and maybe this is my bias, you know, I was particularly, I suppose, you know, captured by your, you know, your pursuit, your quest for knowledge, your pursuit of, you know, your education that had preceded your, you know, professional inquiry, you know, starting all the way back at the University of Sussex, but a continuous, you know, learning process for, you know, from MIT and Imperial College London, Stanford University. I think that, you know, that kind of richness of perspective combined with, again, your industry experience, again, we alluded to on the call here, you know, 10x Genomics, Meridian Bioscience. I mean, I'd really love to hear about the twists and turns that, you know, you've moved through academically, professionally, that have led you to this, you know, ultimate endeavor that is Omniscope today. So would you be willing to talk us through the adventures of Vijay that got us here today?
Absolutely. Absolutely. I think my adventures and my quest for knowledge are also things which I've emulated from the incredible mentors and influences that I've had in my life. Fundamentally, for me, especially being born into a first-generation immigrant family, you were always learning. So as children, we grew up with 6 languages, and my father was an entrepreneur. So, you know, he would take us to India for timber or to London for trading stocks and shares. And it really made me understand in a very concrete manner that the application of new methodologies to learn is fundamental. Not the application of the technology, but the application of a manner to learn. Because that's precisely what I saw my family do, even in absence of university degrees. They did not have that type of access as immigrants coming into Europe. But what they did give me is a incredible worldview. I got to be homeschooled, and I got to be homeschooled in India and in Hong Kong and in the UK and in Indonesia. And the first thing I really noticed is how similar we all are. We all are trying to pursue happiness, and we're all trying to avoid suffering. And the avoidance of suffering is a huge part of human existence, which is where science and medicine are particularly contributive. The idea of the Hippocratic Oath is to try and do no harm and try to do as good as you can. And particularly in the time going between Europe and Asia, I saw such an imbalance between what healthcare was in emerging countries versus where in Europe we had already a certain level of advancement in public health. And that really started off a journey. So I knew I wanted to do genetics when I was very, very young. And I drove my mother crazy because I started growing peas in our back garden. And I remember that she was like, "What are these peas?" And then I started mucking around with biospheres when I was like 10 or 11. She's like, "Why are there a bunch of tanks with algae next to my washing?" And that was an interesting one. But that came from the fact that I had this incredible education and mentors all the way from high school. So I knew genetics was what I wanted to do. It was a time where, we were still trying to decipher the code of life. And it was an incredible time to go to Sussex and with people like Alan Lehman, who were one of the first individuals to look at DNA damage and repair. I got a pre-human genome, pre-next gen sequencing look at this, So imagine this is the Sanger sequencing using retrotransposons as biomarkers to understand quantitative trait loci and how are things inherited. So it was interesting to be in that before the big technological breakthroughs. And that really gave me a good understanding in research methods and lab techniques, which I think is essential in one's education. I think you need to be able to at least understand the experimental basis of how you're going to understand biology. And that was great. That was great. A great time at Sussex doing that. And I had a bit like many people, a bit of an identity crisis because I was offered a PhD at an amount of money which I would never have been able to pay my bills with in central London. And it kind of hit me. Okay, science is for me the most beautiful way to understand the universe, but it's also a difficult way to pay your bills in this universe. So I had to, think about the balance between curiosity and necessity, the curiosity of science and the necessity of paying one's bills. And, I thought, okay, let me take some time to figure out whether I become an IP lawyer or I do something else. And I went off to Italy in my crisis, and I temporarily became a winemaker. I got really involved in the genetics of viticulture, of making wine in Tuscany. It was a beautiful part of the world. And I got to see how one transforms biology of a grape into the art of wine. And I learned patience. I learned a lot of patience. Winemaking requires a lot of patience, even more than genetically modifying organisms. And during that period in Italy, I did my MBA and I started a journey in PerkinElmer where I had to learn a lot of new disciplines, including analytical chemistry, things like gas chromatography in food purity, air quality, genetic screening. PerkinElmer, also, as some of our listeners may recall, was also one of the producers of radionucleotides, which were fundamental at that time to understanding biology. We used to use a lot of radioactive labeled compounds to be able to give us information. And that was incredible because I ended up in Eastern Europe as well. I ended up in Poland for many years. And again, I saw that science has no boundaries. Science is, 1 kilo of silver is 1 kilo of silver, whether you are in the Middle East or whether you are in Spain. It really gives us all a common language. And it was great to get involved in the food sector, in air quality, because it opened my mind to how many problems are solved by science and the multidisciplinary nature of science. And I got to work with incredible people. From there, I don't think it was skill, but serendipity that I got a call from a company called Illumina, who had just bought a technology called next gen sequencing, or SPS, sequencing by synthesis, in Cambridge, UK. And they were looking for people with that type of commercial background to grow this. And I think one of the most important moments in my life, I ended up joining Illumina very early. I saw the first genome analyzers coming off of the rack. I saw sequencing by synthesis, and I saw this Promethean flame, which finally allowed us to understand the DNA composition of organisms, and then eventually even the RNA and hence their expression at breakneck speed. I mean, all of a sudden, everything that happened in the Human Genome Project, I saw a company saying, we're going to give this and democratize that. And I think Illumina have done a great service to humanity by actually taking science and commercially giving it to millions of scientists for days around the world. Just imagine medicine today without Illumina and without next-gen sequencing. I think it would be very different. So that was an amazing journey, and it was a journey where I got to learn from people like Jay Flatley, David Bentley, who was part of the HapMap project. But it also forced me to acknowledge that now we had more data than we could understand. We had data coming from GWAS studies, genome-wide association studies from arrays. Now, all of a sudden, we had entire genomes. And, a lot of us were kind of like, okay, what do we do with this? How do we work with this? And in fact, that whole idea that very little of your genetics actually influences the outcome, or only 2-3% of minor allele frequencies actually go to phenotype, became very evident. So I realized during that technology to generate data is immensely valuable, but then you need to be able to do something with that and translate it to a clinical outcome. And again, here I was very fortunate because under Jay Flatley's leadership, Illumina, for example, commercialized non-invasive prenatal screening, circulating tumor cells, companion diagnostics. So I saw a company who didn't rest on their laurels. They actually wanted to go all the way and impact humanity, and it was incredibly inspirational. During that period, I also started to study again. During full-time employment, I actually ended up getting an incredible offer to be employee number 1 in Asia, in Hong Kong, for a company eventually bought by Meridian. And here was also, might be interesting to our listeners, I'd had to go back to basics, because what Meridian and BioLine, which was the company I worked for, did was make the DNTPs, or the fundamental nucleotides used in sequencing. They were the premier manufacturer of high-end enzymes, which catalyzed these reactions. This meant that I now not only had learned about the technology with Illumina, but I learned how its constituent parts are made. What enzyme, what base, how do these come together? And this really forced me to go very deep, because I was then selling these products to diagnostic manufacturers, sequencing companies, and it was an amazing time because when I went over to Hong Kong, I got to live in China, I got to live in Singapore, I got to build factories in Japan. I also got to learn to snowboard in Japan at a late life. It opened me culturally, technically, and geographically. Asia was the most important thing, and arguably still is, for many companies' corporate strategies. But it also, once again, married my ethical imperative, which was there are billions of people living in Asia who have not received the same standard of healthcare as other humans. And I think when we talk about public health and about the ethics of it, you need to find a way to give to as many as possible, because all of them feel the same pain as you. And I could see that. I lived through avian influenza outbreaks. I lived through MERS. I saw SARS-CoV-2. I've been through these things in different areas. And in China, at that time, there was a big problem with avian influenza. And it was one of the things where I started to work with the CDC and eventually developed emergency use kits for this pathogen. Um, After that, yeah, had the good fortune then of taking a bit of a break. I went to live in the rainforest in Peru because I think that nature is basically what we base our entire society on, right? I know that's obvious, but I think we sometimes forget it far too often, that we are animals and we are part of a natural ecosystem which works as a system. So that gave me a chance to go to Machu Picchu, to go to the jungle, to live in a very different way. And again, it opened me to one of the most important things, which is compassion. To have compassion for living beings and to make that the core part of your scientific enterprise. Um, I met my co-founder in Galapagos. We'll tell you more about that later. But I met Lynette, my co-founder, diving for hammerhead sharks in the Galapagos, which, by the way, for me was a really big deal because I had my little moment where I could follow in Darwin's footsteps. And of course, nothing makes sense without the light of evolution. But it was such a incredible thing to see hammerhead sharks, iguanas, the light of evolution in this beautiful natural paradise. It also made me aware of how threatened these ecosystems are. And that's something which I now have more of charitable and pro bono work, which I do, which is bringing back forest. After that, I had the very good fortune of being headhunted by Siemens. So Siemens at that time wanted to create Siemens Healthcare, and it was part of the big Siemens engineering transport conglomerate. That again was another transformational experience because I got to lead their diagnostic franchise in Asia. And then later on, I became their vice president of molecular diagnostics. So I completed mergers and acquisitions, and I was part of the biggest listing in healthcare on the DAX because obviously Siemens, the inventor of the X-ray, is fundamental to our industry. That was incredible as well because I got to work with IBM or Lenovo. I started my first ventures in PCR and artificial intelligence. I had at that time already completed my Stanford education whilst working in Asia on quantitative financial engineering because I wanted to marry science with mathematics because I understood that that was the only way to truly understand artificial intelligence and machine learning, which fundamentally is math. And then after the IPO with Siemens, as many humans, my parents started to age, and I had to make a difficult choice between a career in California, in the Bay Area, or being close to my parents. And the choice was obvious to me because you cannot love money. You can love your family. I chose to move back to Europe, and fortuitously, 10x Genomics had been headhunting me. And 10x Genomics presented a very interesting scientific question or opportunity. If we think of disease and health at a systems level, the smallest component of disease and health is the cell. Just as physics looks at the atom or subatomic particles, as biologists, we recognize that the cell is essential. Disease arises at cell. Health is maintained by cells. Therefore, the idea of being able to sequence single cells just, I think, was incredible. And I'd seen the incredible work by Serge Saxonov, the CEO of 10x Genomics, and how astute he had been and how intelligent his decision-making process had been. So I said yes, and I moved to Spain, which has become my home. I love Spain, and I love the quality of science and the people and the ethics. And I basically started this journey of commercializing single cell sequencing. And it was mind blowing because all of a sudden my customers were like, oh, we didn't see that in bulk. We didn't know that that cell was responsible for that pathology. We didn't know that a macrophage was important. Or we didn't know that dendritic cells are activated by vaccines because we had no way to see that. The only way we had to see the world was in this low resolution sort of fuzzy black and white TV, if you want. And all of a sudden, we were seeing things in a granular manner. And then, obviously, I was also part of the spatial revolution because we started to look at not just single cells, but where do those single cells live in a tissue, in a spatial context? So Rather than looking at a muscle as one organ, you could now look at a muscle at single cell resolution. How are those cells talking to each other? What do they say? What do they say from their DNA? How do they express it? Again, it was just another Promethean flame, which society hasn't even yet realized the potential of spatial genomics. But I found it fascinating. And I just met some incredibly smart people. But the smartest person I met was actually Professor Dr. Holger Hein, the leader of the National Center of Genomics Analysis in Spain, who became my customer. And Holger made obvious to me an issue. You can read single cells, but Jeremy, you and I got a lot of cells, right? A lot of cells, right? And the problem that you have, and I know you're a systems level thinker, which I think is something we share. If you want to represent a system, you need to read enough of it. So if I'm sequencing 10,000 cells, but my body is a nation where every cell is a citizen, I don't understand what's going on if I only understood 10,000 of them. And we got literally billions and billions of cells. In immune cells alone, we have 2 kilos of dry body weight, more or less. So we have huge amounts of cells. And that limitation became very, very clear to me with the background as well in machine learning and mathematically, because I saw again what we notably call the stochastic effect, where a small amount of the population is actually very, very important, but they get drowned out by all the other very common things. When you're looking for disease, every cell matters, because if you find diseased cells, you can do something about it before it becomes a systems level problem, right? So if you find a small tumor, it's one thing, but by the time it's metastasized and spread, now you got a bigger problem. So you want to find those cells. And as life would prompt us, I decided to, after 10x's IPO, which was immensely successful, phenomenal IPO on the NASDAQ, my father started to get incredibly ill. And I had just started my degree in public health, which I have not yet finished, because I wanted to give back to society after the IPO. So I said, I want to do things for other people. And I saw what was happening to my dad. And my dad eventually passed away of chickenpox. Imagine, this was a super healthy guy. I, on my phone, had access to everybody in healthcare. I could call up Memorial, I could call up my friends at Siemens, at Illumina. I was very privileged, both from contacts, financially, education, I had it. I couldn't get a diagnosis. This was in full throes of COVID. We didn't even know what was happening to him because he was apparently utterly healthy. And it became so clear to me, out of personal suffering, what defends and treats disease is your immune system. And in that suffering, Omniscope, I think, became a personal life mission for me, because the reason my father passed away was his immune system was not able to defend him from a virus, which children can defend themselves from. His immune system aged. And this, I think you will see with Omniscope, each person has their story, and they don't just bring their science, they bring their compassion. So just in a little bit of time, that's been some of my journey, and I'm very grateful to have had that.
The arc. Thank you for sharing to that level of detail. As you started your historical, the origin story here, that was something that, captured me at the beginning of the conversation, was the right to pursue happiness, and then, you spoke to the disparity in healthcare, and you spoke to all the suffering. And, then, you kind of came right around full circle and ended with how suffering actually brought you, to this current venture, which, I mean, there's something, existential there, certainly. And maybe I'll preface my monologue with saying, I probably have about 10 or 20 podcast episodes just from the narrative arc that you've given me. So I'm going to try to, choose our own adventure here intelligently. But let me see. I mean, first of all, I think this notion of, the first generation immigrant and being around entrepreneurs and, even the uniqueness in the way that you were schooled, to expose you to 6 languages. And, what kind of emerged from that was this, learning methodology, or manner to learn, I think is how you phrased it, which to me is very fascinating. And because, you also mentioned this notion of a worldview, and something that I've been really, let's say, fascinated, in awe of, and open to, is exactly what you described at the beginning. And that is the learning arc and the learning methodology. Because now, in the age of access to information, and not only access to information, but access to tools that can turn that information into knowledge, and, technologies that can transform that knowledge into wisdom, given that we've been serendipitously, fortuitously, providentially blessed with the privilege of learning, now in the face of all these emergent tools, it's like the learning is never ending. And to some, that might feel daunting. But I do think at the core, there is that necessity of the learning methodology. You mentioned the systems thinking and systems practice. And, Peter Cheklin, I think, was way ahead of his time years ago, and writing on this notion of soft systems methodologies, really where what we're talking about is, moving away from, the, call it, say, the goal Newtonian physics, moving more into Einstein physics, where, it's a lot messier than we thought. And I think, like, the further that, because just imagine a spectrum of science of, they call it pure basic science, as something like, physics. And then it becomes more complex as you move from physics to chemistry to biology to psychology to sociology. And then, as you mentioned, the universal language is something like mathematics. And by the way, it's like all of those subjects are defined, right? I mean, nature, as you mentioned, that's not necessarily how it presents. It's really more that we interpret it that way. But, science is our tool, and our methodology of pursuing, what is true. And I really liked, actually, one of my guests was with, Zymo Research, who I visited in Irvine recently. They had this, I really love their mission statement. It's, well, there's the who we are, but, what we stand for is, the beauty of science is to make things simple, right? And so, you mentioned your learning in science, I think, turned you into, don't let me put words in your mouth, but like into a truth seeker of sorts. Because basically, it's like, if we are able to, I think, see things more clearly and, move, outside of myth, not that that's not valuable, it is, we can start to, predict things that might cause us harm, and in fact enrich for things that would lead to human flourishing. So I just wanted to kind of stamp that, let's say, philosophically, but then more practically, hearing you go through your journey, from, Mendel's peas to the world before next gen sequencing, or like retrotransposons, quantum transposons. Yeah, like I remember doing stuff in sequencing in the lab, crying out loud. My honors thesis supervisor, she was a Rhodes Scholar, actually, under at Southern. And they would run their agarose gels in ethidium bromide, and back then they didn't know it was carcinogenic, and they wouldn't use gloves. So it's like, a nod to those people in the labs that, sometimes unknowingly, put their lives at risk. But yeah, like just hearing all the lab stuff that I forgot about, like DNTPs and optimized enzymes, and remembering that when those things break, your experiments break and you can't get to the truth. And, so much of my time, academically, I didn't have the appreciation for the industry, confluence and synergy that I think necessitates progress, which I guess is what now that I think about it in hindsight, which is what captivated me in your profile. Learning more about, again, it's like you have a visceral affinity, clearly, with the science, and the and compassion to learn and teach. So here we are, been through these twists and turns, and multiple paradigm shifts. And I love your vernacular, this Promethean flame, right? Because it's like it almost feels like every day there's a new one combusting. And you're here now, or at probably one of the, I don't want to say a last frontier, because that would be short-sighted. But there is something to be said for that frontier that you're pursuing in the context, specifically in the immune system, with all these different multi-omics endeavors, and even just to kind of pull one final thread on that single cell problem, I remember thinking the same thing. It's like, well, you're not going to know fully, truly, accurately the full extent of the diversity of the population of cells that is you unless you sequence them all, and then you'd be dead. And I used to think that like 10 or 20 years ago. But now, like, hearing you just kind of talk through all the different ways that we would measure, right? And create maps, and they were fuzzy maps. And that, it makes us remember that's just it. It's a map, and the map is the paradigm, and the paradigm in the map, it's not the landscape. I do imagine ways in the future where maybe we can quantify every single cell. I don't exactly have, an answer for that, but, just something recently, which is, kind of, I think it's synergistic to what we're talking about, but even the genome itself, now new ways of seeing it with these advancements with alpha genome and presenting this unified AI model to decode the genome, which now, allows us to look at these long reads of 1 megabase pair and start to pull into context, gene expression and splicing and chromatin assembly and factor binding. Anyway, so much more. And, so much that it can feel overwhelming without, I suppose, like a hierarchy, right? Because, I'm glad that you mentioned the cell, because that's one of the things that I've been, relearning from Checkland is like through hierarchy, by understanding hierarchy, which I think is essentially what we do insofar as defining the boundaries of, a biological life where emergent properties happen, right? So it's like, you start to see, like in organelles, energy production, you start to see in cells, cellular differentiation, and, and then clusters of cells, you have tissues, right? And then tissues coming together and you have a full body. And, it's interesting to even, contemplate where do we, kind of draw the edges of our, cells, humans as organisms, with the space between individual humans, but now looking at collective societies and citizens and the emergent property of, call it a family versus a town versus a city. So it's really fascinating to walk with you from yes, we go down to kind of the reductionist paradigm and level, but we've somehow got to this, emergent discussion through systems thinking, which I can appreciate now. Your work with 10x Genomics was probably certainly something that, reinforced that. And so now as you enter into, the pursuit of your current venture, so the work that you're doing, most notably in the immune response at Omniscope, I would love to see now how you're taking all of this foundational knowledge, and seems to me you're about to go real deep and narrow again. And then you're going to kind of go down that well and come out, I'm sure, with paradigm shifting insights. So I'd love to learn, how Omniscope got started. I'd love to learn more about your co-founder and that chance meeting in the Galapagos. And you have some really interesting projects. You showed me a living, breathing digital twin model, which, a healthy immune system versus unhealthy. And it kind of reminded me of, I don't know if you've seen, I think it's the second Avengers when, right. He has Jarvis gets hacked. And so he's like all broken. Yeah. So you kind of I looked at it and it captured me visually. And so I think you're already there insofar as I'm going to go in deep, but I'm also going to show you a picture of what this looks like. And I'm actually going to point to what this means. And I know you've done your own. I know you think you can talk about the numbers, but I know there's also different interest groups. Like you've looked at athletes, and, in the world of, chronic disease, ultimately the source of, chronic inflammation, which, is to a large or full extent, basically a runaway immune system. I'm interested to see how, your vision has evolved since, you founded the company around 5 years ago, what it was like when you started, where it is now and where it might go.
I think that's a topic, obviously, which I find I have a lot of passion for. But let's take just a step back to some of the notions you mentioned. First of all, I think to a lot of us, complexity is scary and it's overwhelming. Whether it's trying to understand a complex system like the financial system or medicine. And in medicine in particular, we've made incredible advances. But we have also increasingly specialized and taken a system which works together and said, no, this is orthopedics, this is respiratory, this is cardiology, this is oncology. And I think we've achieved a lot through that. And it is important to note that that approach has increased human lifespan to past 73, 75 globally. Globally. So we also have to acknowledge that we have achieved a lot, and we have overcome many disparities. I remember growing up and having a few of my relatives who, a few months after being born, died of gastric and gastrointestinal pathogens. That was reality. It wasn't something unusual. Now, the price that we paid for that is we sacrificed systems level thinking. So let complexity in our journey together with our listeners, let complexity be something that we talk about and aim to resolve. And let systems level thinking be the methodology to solve complexity rather than being overwhelmed. And rather than siloing things down in a excessively reductionist manner, let us use reductionism, being understanding of its fundamental limitation, that it may tell you how a village works, but let us not try to infer that to how a New York City works. Let's try and understand. So based on complexity and based on systems level thinking as our anchors, if we are a bit excessively reductionist, just temporarily, and we think about health, your brain is really important. Really important. It's the central command center. We know that. It literally is going to tell everything, every other system what to do. Make hormones, beat your heart should beat faster, repair that muscle, watch out for that pathogen. Now, the brain is the central command center. But just as a country, you cannot only have a centralized system because it will fail. Evolution will punish it, you will die. You need a distributed command center. You need distributed soldiers. You need distributed repairers. That is your immune system. Over 500 million years, nature came up with a quasi-universal way to figure out how to defend you from disease and how to treat it. And it's quite conserved amongst a huge group of species. So, if you look at vertebrate immune systems in 500 million years, surely you'll find some idiosyncrasies. Llamas don't have T cells, and sharks have T cells which undergo hypersomatic mutation, which is quite unusual. But by and large, most living beings have converged upon the immune system as a way to defend and treat themselves from disease. And they have converged upon some form of cerebrum in order to command these systems. The thing about the immune system is that we know how to manipulate it and use it for health. Vaccines. We've been doing that for ages and ages, right? A vaccine basically trains your immune system to recognize a pathogen and to treat it without a huge biological cost, without illness, by doing what? By training it, literally, by giving it a little tiny part of the pathogen. And then the immune system recognizes it. And especially your T cells do this completely, I think, fascinating thing, which is they clone themselves into millions and millions. So you have millions of T cells for one pathogen, and basically you are able to overwhelm the pathogen. Your B cells produce antibodies so that you have this soluble way going through whizzing around through your blood to tag the bad guy, to tag tuberculosis, to tag influenza. I mean, just take a step back and just think of how cool that is. You have this cellular army which has B cells which secrete antibodies. So they're just whizzing around, circulating, latching on to whatever is bad. And then you have T cells which home into the target. Literally, they go up to the disease cell and they kill it. It's incredibly, incredibly exquisite. And it works as a system, right? You've got your immune system circulating in your blood. You've got immune system in your lymph nodes. You have the thymus, which is producing huge amounts of these and unfortunately stops producing them as we age, which is a topic we'll come back to. And you also have what we always have in biology, which is it's not perfect. So those same immune cells cause allergies, autoimmune diseases, right? I mean, you can eat a peanut or a shrimp, and if you're extremely allergic to that's going to be really bad for you because the system has trade-offs. It's an imperfect system. And autoimmune disease is exemplary of that. It's the soldiers, your T cells, which should protect you, all of a sudden attack your joints and cause rheumatoid arthritis, which unfortunately, many of us, as we live longer, will have these sort of afflictions as part of living longer. So it's an imperfect system. It's a system which is, we talk about inflammation a lot, but what produces inflammation, what produces IL-6 and cytokine storms? Your immune system. Your cells are the ones producing that. So there's the good bit that when they behave properly, they detect and they treat disease. There's the bad bit, which they do autoimmune diseases, inflammation. And for example, let's take something like cancer. They aren't doing their job properly, right? If you look at cancer from a cellular systems level basis, cancer is rogue cells escaping the control of your immune system. Your immune system should kill them before they take over the entire system. But it does not. It is a system breakdown. So coming back to our anchor of complexity theory, we thought, should we try decoding the brain? And, that's not something which I'm good at. I don't know enough about neuroscience. Can we decode the immune system? That is a cellular problem, and one in which particularly my co-founder and chief scientific officer, Professor Dr. Holger Hein, already had experience. You see, Holger had already started the Human Cell Atlas initiative with Sarah Teichmann and Aviv Regan from Cambridge and now notably from Genentech. And Holger already understood that this was going to require technology. So indeed, Holger co-chaired the technology working group for the Human Cell Atlas. And the idea there was, let us understand human biology cell by cell. Let's build tonsil atlases, brain atlases. Let's look at each of these systems and let's try to understand them a bit, like you said, at their village and their city level, because eventually they're all going to unify and we're going to have this data, right? But the problem with complexity is that in order to understand a complex system, you need a lot of data of it. If I want to understand a nation, I perform a census. If I want to understand whether Spain needs another cancer center, I look at public health, information systems. And the problem that we fundamentally had was, how much information did we have on the immune system? Very, very little. I mean, if you ask people, how many cells do I have against influenza? I have no idea. But here's an influenza vaccine. How do I get my immune cells to kill that tumor? Well, here's pembrolizumab. Immune checkpoint inhibitors will take the brakes off of your T cells, but we don't know exactly how and why. What does that result? What happens when you start touching a complex system like the immune system without the data to understand it? Pembrolizumab works in 15 to 20% of patients. Why? Women suffer massively more autoimmune disease than men. Why? Why do we become more vulnerable and susceptible to disease as we get older? Sure, your immune system is aging, but what do we mean by that? We had a huge data scarcity problem. So I think the brilliance of Holger was to develop a technology which read 100 times more per sample than any other technology out there. Now, I want to repeat that for our listeners, 100 times per sample. Okay. So let me put that into context. When we first started the company, our first sample, which basically yielded 1 million cells, was larger than the entire clinical trial of a major pharma company which had gone on for 5 years. one sample. They basically had around 150,000 cells. We had 1 million from one sample. That was the paradigm shift. And now we had the second challenge, which was, yeah, but how are we going to understand not Holger's immune system, but Jeremy's immune system, the immune system of our fellow human beings who we endeavor to help? And I think this was the incredible work of my co-founder, Lynette Ang, who I met in the Galapagos. You see, Lynette came from asset management, and Lynette grew up in Singapore. So one of the first things Lynette said is, we need to build a sample database which represents humanity. And she came at it saying, we need to represent women, we need to represent men, we need to represent newborns, we need to represent the old. We need to make sure that what happened to my sister doesn't happen to others. You see, my sister's HLA type, or her immune type, is not one which is frequently looked at in clinical trials. So when my sister got breast cancer, all of a sudden, a lot of the therapies out there were not actually made with her in mind. They were made with other populations in mind. And that's fine. That happened in the past. I want to make the future better. So we started from day one by ensuring that humanity was captured in the world's largest database of the immune system. And then we started the journey of literally, I mean, I've been to some real interesting places for samples. I've seen 104-year-old 100-meter sprinters in Japan and newborns in Finland and conserved populations from there. So it's also, quite frankly, very exciting, because you get to go and meet people and get samples from, folks who have responded to a vaccine, folks who had an adverse reaction to a vaccine, folks who have cleared cancer, and folks who have not. And by creating all of this data, which now has resulted in a database of vastly over 1 billion cells and thousands of patients from around the world, we then had the next challenge, which was, if I thought that NGS gave me a lot of data, this was just on a different one. This was in a different one. Like, we got the first data sets, and I remember Holger, myself, and Lynette going, oh my goodness, how are we going to analyze this? Like, I mean, we had 7 million cells. Again, just to give you an idea, most of that work at that time was using things like Excels and spreadsheets. So you basically had a spreadsheet which had 1 million rows, and basically no computer that we could find running it locally could look at that data. So we were very fortunate, because the government of Spain was immensely supportive and actually came in and gave us the supercomputer at the National Center of Genomics Analysis, without which we would have never been able to actually use that data. And here, I think it's important to note that curing somebody, helping somebody, means that you're always in the hands of another human, in the hands of somebody else who has learned something else, who has learned another branch of science, for which you owe immense gratitude because it solves your problem. The supercomputer was not necessarily designed to read the immune system, but it worked. And that really opened our eyes to a lot of things. It happened in the throes of the pandemic. We were seeing a lot of people we loved passing away. And we wanted to answer questions such as, why is it some people are getting such adverse reactions to COVID, whereas others are completely asymptomatic? And it allowed us to interrogate the immune system and really see how T and B cells are responding, elicited to the vaccine, and for how long do they hang around to protect you. This was also at a time where people were giving booster shots without looking at the immune system. They were just looking at antibodies. And what we were seeing was, no, actually, the antibodies, they disappear after a while. But those T cells, the beauty of your immune system is that it hangs around for years. And we realized something which I had read many times, but I didn't appreciate it. Your immune system is the inheritance of your species, of the ancestral species, your last common ancestors before humanity even emerged. And then you inherit a bunch of it. You inherit a bunch of your immune system from your mother, because she gives you your first antibodies with you an immune system. Your immune system is also given to you through the microbiome, which it's fascinating, right? Like you and I, Jeremy, are sitting here, but most of us is viruses and bacteria. And your immune system is tolerating them and has this great relationship with them. And it comes back to the beauty that your mitochondria are not even yours. And there's so much of you which is dependent on another cell. And your immune system regulates that. It says, hey, don't touch the good stuff in your stomach, but there's some bad stuff. There's a Helicobacter pylori, there's a C. difficile. I need to do something about that. So we started building the database, and we basically rationalized that we should look at the major diseases affecting humanity: cancer, infectious disease, autoimmune disease, obviously cardiovascular disease, which I will come back to, because a lot of cardiovascular disease is also linked to the immune system. Recent research shows that heart attacks, in part, have an immune crosstalk with the brain. And we now know that a lot of what we characterize as neurodegenerative diseases actually have immune cells entering the cerebral spinal fluid and going up to your brain, causing brain lesions. Multiple sclerosis is a perfect example of that, where brain lesions are caused by immune cells in what is a both autoimmune and neuro disease. So you can already see that under the lens of the immune system, the old style of disease classification starts to actually break down. And you actually see things for their cellular pathology rather than their symptomatic pathology. And it also then, I think, opened the biggest question for us. Like this, we had a real major problem, right? So we've got this huge database which we're building. It's growing every day. And people say, well, that's disease, that's a cancer patient, and that's a healthy patient. So I remember at one point we said, yeah, but what do you mean by healthy? And this is for our listeners as well. What do you mean when as a listener, when you think of healthy, what do you think of? Is it not having a disease? Is it performing and functioning at the top of your game? Is being healthy living for 100 years? Is being healthy dying at the moment of life expectancy? We use, even in public health, we use this word health in a very, I think, questionable and sometimes complicated manner because we've not defined it. So we as a company decided that we wanted to tackle that. And we started to look for what healthy means at a cellular level. What is a healthy cell? So that I can then use artificial intelligence and classification to say this is healthy, this is not. This is early disease, this is not. Now, sounds simple. I promise you, as a co-founder of Omniscope, it was not. And luckily, our labs are situated in a beautiful part of Barcelona. Come and visit. It's right next to Football Club Barcelona's Camp Nou, where Football Club Barcelona athletes play the beautiful game of football. And it was late at night. Holger and I were in the lab. A lot of our teammates were around us. Our founding team is very important to us, with the people with whom we built the company, who I don't think get enough praise. We're all there late at night, not watching the football game, but working. At that time, we had a large cancer cohort. Anyway, we're looking outside and we're seeing the players enter the team. And we sort of looked at each other and we said, wow, those guys and those gals, they're really healthy. I mean, they're so healthy, they can sprint across that field. They've got amazing reflexes. How is it that they never get sick? It's freezing. Everybody else has influenza. And when you have those eureka moments, Jeremy, that was our eureka moment. We were like, that's healthy. That's what healthy is. What do I want to be when I say I'm healthy? I want to be able to use my body to its maximum capacity. I want to have the best cognition. I want to be fairly free from disease. And I want to express myself biologically as a living being and do the best I can for everyone around me and be happy. And athletes have that. They tend to be very, very happy. They tend to be free from disease. They can do things which normal human beings can't. And they're hyper functional. And guess what? Athletes have far better life expectancy than other folks. And they suffer the hallmarks of aging much, much less. So they have a lower incidence of cardiovascular disease, cancer, diabetes. They have healthier diets. They have more movements. That's healthy. That's healthy. So we started this mission where we started sequencing athletes, and we actually started to do something different from the work which we had been doing in sick care. So at that time, for example, we'd started with University of California, San Francisco on sequencing HIV patients with Dr. Christian Brander in the efforts of making vaccines and therapeutics for HIV, which has been so hard for humanity to crack. And Barcelona Football Club told us, yeah, you keep doing that, you keep doing the science, but can you keep my players healthy? Can you minimize injury? Can you help them recover fast? Can you help me train smarter? Can you give me a scientific understanding of if I'm giving an athlete a supplement or if an athlete gets injured, how long till they recover? When should I put them back on the pitch? And this was unique because we got to test our technology in the real world. Clinical trials are very controlled. Real life and real science is messy. You can be hale and hearty today, and tomorrow, Jeremy, you might have a bit of a sniffle. That is complexity. That is the course of life. By looking at athletes in real situations, we learned what healthy means, and we learned how their immune systems allow them to fight disease, how their immune systems are so well regulated that even though they're working out every day and they're subject to crazy amounts of stress, they don't get hyperinflamed. They don't get this chronic age inflammation. You've got athletes in their 50s. George Foreman won the world championship at very elevated age, towards his 50s. Floyd Mayweather, unbeaten champion, does not represent the date of birth on his passport. I mean, the way the person functions is far younger. So it really allowed us to understand that to be young on the outside, your immune system had to be young on the inside. And if your immune system fails, disease emerges. So your true age is actually your immune age. And we can prove that because we can see it functionally validated in real world evidence on the field, on the ground. And we moved from soccer to football to tennis. And that was a huge, huge insight, which today we are using in OS Lifetime, where we build cellular avatars cell by cell, and we understand being healthy at a cellular level for your entire health span. The other thing which happened, which might be interesting to our listeners, and I'll sort of postulate it as a question: why do centenarians not only live so long? Why is it that particularly the blue zone centenarians, in the US, we have Loma Linda as one of our blue zones. What is truly different about them? Why are they so functional at such an elevated age? Why do you have a 100-year-old who was pretty much disease-free, sociable, working, enjoying their life, eating well, and yet, especially in our developed Western economies, we've got between 4 to 5 diseases at any given time. 4 out of 10 people suffer chronic disease in young age. They might have an autoimmune disease, a neural disease, and even why and what is different. What actually allows you to live a longer and healthier life? And that started another incredible adventure, both scientifically but also personally, because we got to meet some of these centenarians and take their blood, which they very kindly donated to science. And we developed many collaborators globally. And eventually, we also built the world's largest database of centenarians and even more. And for me, one of the coolest things I ever saw is a 104-year-old who ran the 100-meter sprint. I just thought that was mind-blowing. And what we found was that, yes, their cardiovascular health is better. Yes, their musculoskeletal health is better. Sarcopenia is a major issue when you lose muscles with age. And muscles are your armor because they kind of keep the body working out. Their bones are healthier. A lot of us suffer from osteoarthritis and other bone density and bone health related diseases. Yes, they have great cognitive function. Many of them remember phone numbers from prior to World War II, which is quite something. But There is one thing which all of them share, every single one. And that is their immune systems are way younger than 100 years old. These people are around because their immune system is detecting and treating disease. And as long as you can see that, when we look at the cellular avatar of these people, they are exceptionally younger than their age. Their immune system doesn't shrink and become smaller. And in fact, quite the contrary. Their immune system behaves like a younger individual. This journey going through a balanced database of the human immune system meant that when Google and NVIDIA approached us with partnerships and support, we had enough data not to do things randomly, like let me give you an immune checkpoint inhibitor or a vaccine. We were doing things because we had the insight to act. If you can't measure it and you don't understand it, then be careful before you touch it. And we've developed the foundational model of the immune system, which allowed us to launch Immune GPT, which is our own large language model based on our entire database, which we built over 5 years and continues to grow across major diseases, from newborns to centenarians, from people with diseases to the world's healthiest athletes. And that's how we've started to develop solutions for pharma and biotech with in silico drug design, for longevity and sports to optimize human performance. It's based on data, and it's based on cell by cell data, because in order to understand complexity, you have to understand the smallest component of complexity. And in biology, that is the cell. The only catch is that not all your cells are made equal. You could have decided to study skin cells or another cell, but your immune system is unique. It is so important for your survival that without it, you simply can't exist. So we decided to build a database to decode the most important system to your health. That's a little bit about how we went through the Omniscope data journey.
Quite a journey, putting it lightly. And so by the sounds of it, you've got, well, a couple of exciting opportunities. And I was kind of refamiliarizing myself with your site as you were chatting. And, you had this offer for pharma. You have this offer for sports and human performance. And it seems that you have an offer for, well, healthspan and, wellness and scientific wellness at that, the kind of lifetime operating system. And, something you said there, resonates with, what a couple of my previous guests have said, mainly, Lee Hood and Dr. Lee Hood and Dr. Nathan Price. And that's exactly right. Can we agree precisely on, what healthy is? And, let's agree that it's not to be without disease. Maybe that's an emergent property of being healthy, is not having a disease. And so you've taken this very exhaustive and narrow yet systems approach to creating what, for all intents and purposes, to me looks like an opportunity for like a longitudinal analysis, say from my own personal life lesson. Was my immune system adapting over time, over a lifetime? Then you've got, kind of the tip of the spear with human performance, and then you've got, drug design in the age of AI and the age of 100x sampling per 150K. So now, does this go from, because I know you've been around for 5 years and now you have all these really exciting partnerships happening. Where do you see the delivery of your product? Like, do you see yourselves as a consumer product? Do you see yourselves as, kind of a back end, infrastructure, fueling, obviously the B2B partnerships with the development of therapeutics, but how does like now all of this proof of concept IP that you have, how does it become sustainable for everybody? And I know that's a big question. And so to the extent that you can share, what does the roadmap look like in terms of, the roadmap to everybody, right? Because to point to where we started, it's like, hey, everybody deserves to pursue their happiness, to pursue good health. We want to democratize what it means to be healthy and the information that would get you there. So what does that journey look like from, where you are now at this unprecedented lens into, uh, a challenged immune system, a thriving immune system, and a sustained um, immune system for health span? So how does that look from where you are?
That's a great question, and it's a question which, especially as you design a company, you have to answer, because it's a very tough journey. And if you don't have guiding principles, you will get tired fast. But if you have guiding principles, they will always come back and give you stamina and endurance. We have two very important principles at Omniscope. One is science is we all. That is not a grammatical mistake. Science is we all. That means that in order to do something great, such as decode the immune system, you need a multidisciplinary group of people. We have software engineers, we have mathematicians, we have computational biologists, we have sequencing specialists, we have enzymologists. As a company, we are incredibly diverse. We speak over, I think the last count is 28 languages. But it says we all means our listeners. It means Jeremy. It means everybody. Because by participating in building this database, you are represented. So, Jeremy, if you take OS Lifetime and you use that to manage your immune system for your health span, for a longer, healthier life, you are just not taking care of Jeremy, you're taking care of a lot of other people who will learn from your data, who will learn from your contributions. This is citizen science. And I've always, for example, given blood for blood donation drives. When I was a student, I would participate in clinical trials if I didn't feel that it was going to damage my health. Because if you don't do it, how are you going to achieve it? What are you going to give your children? What will you give to the future? So that's why we created OS Lifetime. OS Lifetime is already available in several clinics globally and is going to be more and more available. Now we're opening up in the United States, Saudi Arabia, Hong Kong, Dubai, London. So we are doing this because we believe in healthcare for everyone, everywhere. And I make no apologies for believing in public health. I believe it is something which we have to give. So by giving the ability to pretty much anybody to look at their immune system longitudinally, because all our databases are longitudinal. So, you would, for example, 3 times a year, you would go to one of our clinical partners. You would take a simple blood draw. We would read your immune system and create a cellular avatar. And maybe in the middle of the year to see how you're doing. Are you managing to keep your inflammation down? Is your immune system reacting to, for example, the vaccines you've taken? And at the end of the year, hey, where did we end up with this year? This replaces the antiquated concept of a blood test, which I say respectfully is based on technology from the 60s and the 80s looking at soluble markers. That does not give you agency over your health. With OS Lifetime, we take all of the data, we build a cellular avatar which you can query, so you can actually use. You don't have to be a physician, you don't have to be an immunologist, you don't have to be an elite athlete. You can literally type in text. It's going to talk directly to your cells, your wearable data, your heart rate, your respiration, your sleep. And for example, with me, it's the way that I personally used it to deal with my psoriasis. I have quite severe psoriasis. At one stage, when I looked at my inflammatory profile, I was inflamed as cancer patients in our database. And I was really, really suffering. My father had it, my brother, myself. And it got to the point where, my physician said, well, you've been taking cortisol for 10 years. I think at this stage, it's really, really bad. Let's just give you some intravenously or some other bits. I said, that sounds really, really bad. So what is your game plan for me? How does this work? Why are you suppressing my immune system? What's going to happen if I get psoriatic arthritis? The psoriasis passes to my bones, which happened to some of my relatives. And the problem that I saw was that my physician, she was incredibly well intentioned, but she just didn't have time to educate me, give me agency, answer all my questions. She had 30 minutes on the clock, and that was because she was just really going out of her way to help me. And I thought, wow, look at all of the other people there suffering really serious pathologies. And they go to their doctor and they hear this report in a language which sounds like English, but doesn't seem like it. So we created Immune GPT and the cellular avatar with OS Lifetime, which is increasingly available in clinics worldwide, so that people have agency over their own healthcare, so that they can understand their immune system, their inflammation, their protection score, their blood tests, their immune age. For example, we include senescence, which many people are now being more educated about. They know that we get zombie cells which refuse to die. Well, how many do I have? Compared to whom? So we've also opened our database because it allows you to compare yourself to a top athlete. It allows you to compare yourself to a centenarian so that you can actually emulate the best examples, not from a scientific paper or 10 years of research from now, but from people who are actually living. You're learning from humans who have already managed to live very well. That's what OS Lifetime gives you. It teaches you the secrets of centenarians, it gives you the athletes, it gives you a lot of non pharmaceutical interventions, caloric restriction. How do you know a supplement that you're taking works? I diminished my inflammation without drugs. So I used high dose vitamin C, I used omega 3s, I used glutamine, I used a variety of non pharmaceutical interventions. But the difference is I could actually see them taking effect. So I've shared publicly in ARDD my protocol. And what I actually showed is I brought my psoriasis flares to zero. I haven't had a flare in months after suffering since I've been a 20-year-old. And I did so without drugs, using non pharmaceutical interventions by understanding my biology. And I'm not suggesting that people don't listen to their physician and take medication. Listen to your physicians. This is a further insight. So that allows us now to fulfill our ethical duty to everybody everywhere. With sport, it's available to professional sports and professional teams. Recently, we did something which I thought was really, really cool. We collaborated with Rafa Racing in Daytona, and we wanted to understand what do G-forces do to the incredible athletes. So one of them, Lindsay, she's driving around in her incredible Lamborghini. She's in great shape. But how do we know when we should put her back into a car going around at 200 kilometers an hour for 5 hours around the ring? What does engine heat do? We've now started to work with astronauts. What does space travel do to the immune system? Can we actually take care of the immune system to allow this next frontier of human voyage? And finally, with pharma, we are focusing with pharma as partners. You see, pharma fundamentally have normally picked up technology from companies like Omniscope, where we create a company and then can license, collaborate, and partner. So we've done a lot of work already in public domain, for instance, with AstraZeneca, where we looked at whether or not their drugs in colorectal cancer are actually working. How do they work? Who responds and who does not? And that's an area, for example, where our work on predicting who will respond and who will not is in the public domain. We've been very, very fortunate with the incredible support of the European Union, the instrumental support of the European Union, with whom we use our technology to understand the immune system in reverse vaccinology. So, for example, Juan Luis Melero, one of our founding team members, is working with Baccerna, where we are looking to develop vaccines for tuberculosis. Tuberculosis is a major issue because it has become resistant to antibiotics. And a vaccine has been largely elusive, even though, of course, we have the BCG vaccines and a few others from the past. But this is designed to literally help the large swathes of people where latent tuberculosis and active infection are a huge problem. And we're also being serious about climate change, also with the European Union, where our work on dengue, Zika, and chikungunya viruses transmitted by mosquitoes are approaching Europe because global warming pushes up the mosquito line. As it gets warmer, all of a sudden, many of you may remember that there were mosquitoes in Paris. Right now, we have the Winter Olympics in Italy. And guess what? You have these pathologies to which we do not have immunity. We may wish to recall that the bubonic plague wiped out swathes of humanity and re-engineered our immune system. So we are actually here developing vaccines against these pathologies. Agenus Therapeutics is a great example where also in colorectal cancer, we showed that their novel CTLA-4 immune checkpoint inhibitor is particularly effective in colorectal cancer. Now with Fox Chase, we have a long-term program to study every single lung cancer patient who enters the hospital so that we can actually match them to the best therapies. And these are just some examples of what we do. But I think the most exciting thing we do with pharma and for everybody everywhere is because we have so much data of the immune system and nobody else has it. So it's our data, it's proprietary data, right? Unlike OpenAI, who need 9 billion parameters and a lot of money to basically understand text and speech, we developed a GPT which allows you to analyze cells and immune cells and actually their function in health and disease. And this has allowed us to do something very exciting recently. We've partnered with a pharma company whose name I cannot disclose, but we are actually, for the first time to my knowledge, using our Immune GPT large language model to develop a therapy for an autoimmune disease. And that actually comes back to some of Holger's incredible work, where in Spain we came across a child born with almost half a kilo of tumor, a rare rhabdoid sarcoma, and she was put in palliative care. So you can imagine how distressing that is. You as a parent have just had a child, and somebody turns around and goes, "Sorry, there's no hope. Your child is going to die." That really, really hit us as humans. We said, no, we want to do something. So we made the proposal that we would start to monitor this little girl as she would receive immune checkpoint inhibitors against her tumor. The problem was that the therapies are designed for adults. So child's immune systems are actually not very well known, even though we keep on giving them a ton of vaccines and stuff. We don't really know what's going on. And their immune system is changing because they're still growing, let alone a newborn. So we started to monitor how she was responding, and our technology was used to guide the therapy. But in the meantime, we knew that the chances that this tumor comes back are very high. So how will we defend her, not just today, but tomorrow? So there we took the data we generated and we used generative AI to create a cancer vaccine which transforms T cells to kill her tumor. And we took some of the tumor and we took those immune cells and we shipped them to Switzerland, to the University of Lausanne, which is headed by George Koukos, who some of our listeners may know has contributed immensely to the field of immunotherapy, particularly ovarian cancer. And what we saw was scientifically astounding. We saw the engineered T cells kill and destroy the tumor in the tube. We literally, in 10 months, $35,000, did what billion-dollar companies could not do, and we proved it. And this technology is what we want to give to everybody everywhere. We want to make personalized immunotherapy, personalized medicine, using your immune system to heal you, reality. And it's not science fiction. We already did it. And actually, Google gave us a huge amount of support there as well, because rather than using supercomputers, it was there that we moved to cloud computing. And now ImmuneGPT is developing therapies at breakneck speed, but we always validate them in the real world, in real biology, because you should not trust a computer. You should trust what you empirically observe in biology. So we married the two to develop a loop where we read your immune system, and we use it to heal you.
I wish we had 2 more hours. I knew this when we started talking, that was going to be my wish towards the end. But being respectful of your time, I know that we're coming to an end. But if you'll indulge me with 3 questions, I promised I would ask at the beginning. We can work on this home stretch together. Does that work for you? Amazing.
Absolutely, sir.
Okay, so number one is, we've been through this incredible molecular odyssey, putting it lightly. It'd be great to be able to distill this down as, what's the key takeaway for our listener here today? And above all, listeners, like, do you have an avatar, a key listener, like, who would need to hear this the most, would be question number 2. And then question number 3 was, who would you nominate as my next guest?
Yeah. Look, I think the key takeaway, for me, there are two key takeaways. One of them is as a humanist, and the other one is as a scientist. We live in the hands of others. Today, I'm in your hands. You're interviewing me. Tomorrow, I may be in the hands of one of our listeners. Might be a doctor or a personal trainer or a musician. We live in the hands of others, so we must respect other living beings, and we must understand that we are in a beautiful system, which is also chaotic and dangerous. So it is up to us to make it beautiful and safe. This is something which I carry very deeply in my belief. The second bit is, you do not have to wait for the future. Today, you can use your immune system to live healthier, longer lives. You can use your immune system to play the beautiful game, whether it's basketball or swimming or whatever it is, because sport is not a pill, but sport is a medicine. And being able to measure it is one of the most powerful things you can do to your health today. And the way you can do that, very simply, we have an early access sign up on our website for OS Lifetime. In Spain, it's already available with Barna Clinic, which is led by Dr. Jude Rodas, who formerly took care of Lionel Messi, and Dr. Eva Ferrer, one of the best women's health and women's sports specialists, also taking care of FC Barcelona. So for anybody who's in Barcelona, we have our clinical partner, which is absolutely world class. You can have your immune system read, and you can have a physician help you walk through how to use that, integrate your wearables. Know yourself through your own cellular avatar, know your own biology. Don't be afraid of complexity. AI actually is useful to understand that. So that would be my first thing, is sign up, do sports, and be nice to other people and other living beings, preferably, not just people. The person who has inspired me the most as a human being is Holger Heim, who luckily is my co-founder. I think he is an amazing, amazing individual, and he has a lot to give and a lot to say. The person I think you should interview next is somebody who I consider one of the most important figures today to actually help us solve the aging crisis. And that person is Dr. Mahmoud Khan, the CEO of Evolution. Dr. Khan is an incredible physician who has dedicated his life to putting practical solutions to actually solve aging from geroscience perspective. He's also somebody who has played an incredible role in a variety of companies. Evolution is the largest investor in geroscience and gerotherapeutics in the world, which I think, if there's one thing that all our listeners are sure about, is that eventually age and death will get you. So this is a man who I think is taking a very rational and compassionate approach. So I think you should interview Dr. Mahmoud Khan next. And you will have to forgive me. There was a third question, or did I overcomplicate it?
No, I think you answered it you answered the 2 in 1 insofar as, what's the key message? And I said, who would need to hear it? That was number 2. And then number 3 was the next guest. So I think you've nailed all 3. So thank you very much.
Everyone. Healthcare for everyone, everywhere. We all, I think everyone should understand their biology.
Amazing. Listen, Vijay, we're going to have to definitely do another episode, but, in the meantime, I want to thank you for, all the incredible work that you have done, you are doing, and no doubt will do. It's been a true pleasure and honor to host you today. Thank you for the time.
Same here, Jeremy. And one thing which I want to thank you for, aside from the fact that you share this with listeners, is the incredible work that you have done as a scientist. So it's an honor to speak with you, and thank you so much for sharing your time.
The fuzzy map has been exposed. Vijay revealed that the difference between a centenarian sprinter and a hospital patient isn't just luck. It is the specific trainable intelligence of their immune system. We now know that health is not merely the absence of disease. It is the presence of a vigilant, youthful cellular army. So here's the question you might now carry with you. Are you awaiting for a crisis to reveal your biology, or will you seek the signal while you still have time? The technology to decode your immune age exists, and the insights from the world's most resilient humans are available, and the code has been broken, or at least it's breaking, and the days of guessing are coming to an end. Given to be the time that we can move from being a passenger in our bodies to being its commander, to understand the signal, to activate our defenses, and to become the architect of our own health span.